So we're going to walk through the law of signs, which is usually a fairly straightforward rule. But there's one way that you can be given information in law of signs that is complicated, and that is the ambiguous case side-side angle. Every textbook ever and every teacher ever writes it as side-side angle, because if you write it the other way, it's ASS, which is often considered to be a bad word. So teachers don't write ASS on the board because kids will laugh, but it kind of is helpful to remember that that's the case where you run into a problem with the law of signs. So if that helps, so be it. All right, so in this ambiguous case, we're given, so this side-side angle, right? Oh, this is on page 412 in the textbook I use, which is the Larson Pre-Calculus 6th edition. So let's talk about what you're given in this case. You're given angles angle A, big A, side A, and side B, right? So you're given big A, and little b, right? And it's worth noting that in this triangle, the height of the triangle, right, the altitude of this triangle is going to be B sine of big A, B sine of A. All right, so if you're given this case, this angle and then two sides, right, ASS, so you're given this case, there are 6 different ways that this can pan out, and honestly, most of the time, it's not a big deal. If you're doing this as a multiple choice test, you're going to tend to find that it's not an issue at all unless there's some answer that says no triangle possible or none of the above. So most of the time, it's absolutely fine, not a big deal. But let's walk through the options. So we're going to start with the acute options because my board is only so big, so I'm going to start with the 4 options for A being acute, and then I'm going to talk about the 2 options where A is obtuse. So option 1, if A is acute, right, meaning smaller than 90 degrees, and A is smaller than the height of the triangle. So what that's going to look like is that you have some set angle A, right, some set angle A that is acute, right, there's my angle A, and then this is your little side B, right, that's next to A. And then you have this little side A over here, right? So here's your side A. But the problem is that A is smaller than the height of the triangle, which would be this altitude right here. And because A is smaller than H, this A can't possibly come down and touch the line extending from angle A, so there's no triangle. There's no possible triangle. This is a weird case where there's not a possible triangle at all, right? The second case is that A is acute, and the height is the same as, so again, this red dotted line was the height. The height is the same as A. So that would be the exact same triangle I just drew with my big A angle and my big B, or my little B side, right? But now, this height that I have here is actually A. So what's going to happen is this red dotted line that was the height in the previous drawing, the height before was longer than A, but now A is actually the same as height. So the answer is that there is one possible triangle here, and as a side note, it happens to be a right triangle. So not only is it a triangle, but it is a right triangle. The third option we have is that A is acute, right? So that same angle A that we've been drawing, so I'm going to draw the same exact A because I'm lazy and I'm just going to keep drawing it. So A is acute, and A, side A, like little a, is longer than B. So if I use my hand to mark out how long B is, A is something longer than that, so somewhere over here, fine. And there's exactly one triangle that is created by that picture. So A is a bigger side than B. All right, so then let's talk about the option number 4, which is the one that's kind of complicated. So number 1 was a weird option because there was no triangle at all. Now, if A is acute, so I'm going to draw the same A that I've been drawing every single time, or within reason, I'm going to try to, right? So A is acute. I've got this side B, but now, let me do a slightly better job of giving myself a little bit of room, actually. Okay, so there's my side B. Okay, cool. So now, my A is going to be smaller than B, but bigger than the height. So here's the height, right? That same red dotted line that we've been using for the height. But A is going to be a value that is smaller than B, but bigger than the height. So what that means is that A could fall on this side, or A could swing through and sit right here. So what happens is I end up getting 2 triangles. I end up getting this blue triangle that's created right here, right? And I end up getting the other option, which is the triangle that I'm going to outline in red right now. So this whole triangle would have the same angle A, and side B. So either the blue triangle or the red triangle. So 2 triangles end up being created by that weird case. So again, that's an ambiguous case because the possibility exists that 2 different triangles could be drawn. Now up at the top, I'm going to erase my, my case 1 and case 2. And I'm going to talk about what happens if A is obtuse. So we'll see if I can successfully erase this without completely having to redo everything. Okay, so let's talk about what happens if A is obtuse. So we'll call this case 5. and case 6, if A is obtuse, right? So now, if A is obtuse, and A is obtuse, so our two cases are A is obtuse, so we have A is less than or equal to B, and then we have A is bigger than B. Okay, so if we draw this, we're going to draw A to be some like random mystery obtuse angle, right? So there's A, right? And B, well, here's the problem. If A is smaller than B, you can see that I need to get A from here back to this line. Well, if we measure B is this long, right? Well, A is supposed to be shorter than that, and you can see that even if it was the same length, it's either shorter than or equal to that. There's no way that it reaches, so there's no triangle, right? If we do the same exact obtuse picture, right? If I draw one where my angle A is this obtuse angle, right? And here's my side B. And now A is bigger than B, and so now A can reach all the way back, and we get one triangle. So those are the 6 possible cases if you have an ambiguous case problem. Again, I don't think it's very likely you're going to see very many of these. It's not frequent that a teacher gives you one of these and then asks you to solve the triangle, because we're not usually trying to set you up for failure. But the ambiguous case does exist, and if you are given an angle and 2 sides, so it's a non-included angle, right? It's not side, angle, side. This is angle, side, side. If you're given that situation, then you could have an ambiguous case.